All right, we're going to talk about the AC shortcut method, which is a different method than AC grouping. So use whichever one you like. This one in particular, we call it a shortcut because it's a little bit less steps and it's not necessarily mathematically sound. So first of all, we've got an A value, a B value, and then a C value. So start by multiplying the A and the C. Okay, so 7 times 3 is 21. Right, now we want to find the factors of AC that add to B. Okay, so the B value is 10, and the factors of 21 are 1 and 21, and then 7 and 3. And look, as you notice, that 7 plus 3 equals 10, so we're good. Okay, step 3 is write the binomials with the factors that we have. So I'm going to write x plus 3, and then x plus 7. Here it does not matter the order. And step 4 would be divide the factors by A. Okay, so if we divide by the A value, that we notice that the A value is 3. So I'm going to divide the factors by 3, and I'm going to divide by 3. And the last step is simplify, meaning that if it is not an integer, move the value to the front. Okay, if it is an integer, we can just simplify. So for example, x plus 3 divided by 3 is 1. And then 7 divided by 3 is 7/3. So what we're going to do is we're going to move that A value to the front and write 3x plus 7 and then check. We are done. All right, so let's do that again. Okay, the AC shortcut method. Multiply the A and the C value. Okay, so 3 times 4 is 12. Step 2, find the factors of A and C that add to B. And this is another pretty straightforward one, right? So 3 times 4, we've got 2 times 6, and we've got 1 times 12. But very clearly, 3 plus 4 is 7. So 3, write the binomials with the factors. So we know the factors are x plus 3, and we know the factor is x plus 4. Step 4, we divide the factors by the A value. So the A value in this case is 3, so if we divide by 3 and divide by 3, we're going to check out these values and simplify. So we've got x plus 3 divided by 3 is 1, and then 4/3 is not an integer, it's a rational number. So we're going to move that 3 to the front of the binomial and write 3x plus 4 and check. And as you can see, these first couple of examples are prime leading values. So here we go again. Let's take a look at this, right? We have an A value here of 3. So we can't just do sum product. We need to multiply 3 times 10 first. Okay, so find the factors of A and C. So we got 30 now, so 1 and 30. And then here, I should write it like this, 1 times 30. And then we've got 2 times 15, and then we've got 5 times 6, and then we've got 3 times 10. So those are all the factors. So which one of these factors adds to 17? Well, 2 plus 15 is 17. So we're going to write the binomials with the factors. So I'm going to write x plus 2 and x plus 15. Step 4, divide the factors by A. So we know that A is 3, so if I divide by 3 and I divide by 3, now we're going to simplify. So notice this time the first binomial is not an integer, so I'm going to move that 3 to the front. So I'm going to write 3x plus 2 is going to be my first binomial. And then my next binomial, we've got x plus 15 divided by 3 is 5. And then check, you see that everything works out nice and neat. Okay, let's just get in the rhythm now, okay? Let's do it a little bit faster here. A and C, 5 times 8 is 40, okay? Now, using our calculator, if we wanted to get a little help here, we wanted to figure out what the factors of 40 are, we can do 40 divided by x. And then in that, we can just hit the table button. And now we have all the factors, okay? Ignore the decimal and just look for all the factors, okay? So if I'm looking at all these factors here, what two numbers add to 14? And then here you can see that 4 and 10 are going to be the numbers that we need, because 4 plus 10 is 14. So now write the binomials with the factors, x plus 4 and x plus 10. Step 4, divide by the a value. So if I divide by 5 and I divide by 5, last step is simplify. Okay, the first binomial, the 5's got to move to the front of the binomial, so I'll get 5x plus 4. And the second binomial is an integer. 10 divided by 5 is 2, so I'm going to write x plus 2. Check, and we are done. Now, the one thing that is common here with all of these is that you can see that we have both positive values, right? We've got pluses and pluses and pluses and pluses and pluses and pluses. Now we're dealing with a negative value, so you have to be a little bit more careful here. And what I mean is, when I multiply 3 times negative 5, I'm going to get 3 times negative 5 is negative 15. Okay, so if you wanted to use your calculator, let's get in here. Negative 15 divided by x, and then go to your table. Okay, now out of these numbers, what multiplies to negative 15 and adds to negative 14? And if you ever see this, if they're ever close to each other, right, the key is that we're going to have negative 15 times positive 1, because they're very close to each other. So if I write negative 15 plus 1, I get negative 14. So be very careful when you're looking at these factors. Right here, if I go all the way down here, we can see positive 15 and then negative 1. But also, if you go up here on your calculator, you can also see negative 15 and then positive 1. Right? So watch out for that. Now we have to write the factors, and here we have to make sure this time when we're writing the factors, we have to write x minus 15 and then x plus 1. Okay, so these factors are going to be divided by the a value. Again, the a value is 3 here. I probably should have chose a little bit more examples without 3. But we see that x minus 15 divided by 3, that becomes x minus 5. And then the 3 does not yield an integer, so we're going to move it to the front and write 3x plus 1. Check, and we are sound, ready to go. Okay, so as they get a little bit more challenging, you have to watch out for the signs. Be careful with the positives and negatives. Okay, all right, let's try it without the written steps. Okay, we'll try 3 more examples without the written steps. Okay, so step 1, we're going to multiply the a and the c value. So 3 times negative 4 is negative 12. If you want to go to your calculator, go to your calculator and type negative 12 divided by x, right? So it's going to substitute x in, and then you're going to find your values here. Just ignore all the decimals and see, look, negative 12 and 1, right? Negative 6 and 2, okay? Negative 4 and 3. So step 2 is which of these factors, right? Let me double check, make sure I'm at step 2. Yeah, which of these factors add to b? Now here, the b value here is technically 1, a positive 1. So if we list the factors, we've got 1 and 12, and then we've got 3 times 4, and then we've got 6 times 2. But remember, one of them's got to be negative. In this case, what we want to see here is that 4 plus negative 3 will give us positive 1. So if I go down here, I've got 4 and then negative 3 in my calculator. All right, so step 3 is, okay, write the multiples, okay, with the factors, right? Write the binomials with the factors. So I'm going to write x plus 4. And then x minus 3, and then we have to keep in mind the a value. If a is equal to 3, which we did in all of the examples here so far, I've got x plus 4/3, and then x minus 3 over 3. And the last step is simplify, right? So the last step here, we're going to say, well, if the 3 doesn't yield an integer here, we're going to move it to the front and write 3x plus 4. And then 3 divided by 3 is 1. So check, we are done. Now moving on to 2 more challenging ones here. Okay, now we have an a value of 2 and then b value of negative 19 and the c value of 35. All right, so step one would be multiply. So 2 times 35 is 70, okay? So now what factors of 70 add up to negative 19? Now here's a trick. If we know that the last value is positive and they add to a negative, that means that both of these numbers have to be negative numbers, okay? So what two numbers work? All right, now 70 is a pretty large number. It's got quite a few factors, right? So if I'm going to type in 70 and I'm going to divide by x, right away in my table, if I know I get a negative number, you gotta just start looking at negatives, okay? And if we look at all these factors, which ones add to negative 19? And right here we go. We found it, all right? We've got negative 5 plus negative 14 is going to be negative 19, okay? Once we find it, step 3, write them in the binomials, x minus 5 and then x minus 14. And then our a value is 2 this time. So step 4, write them with the a values. 5 divided by 2, and then x minus 14 divided by 2. And the last step, you should see if this 2 does not yield an integer, move it to the front, 2x minus 5. And then x minus 14 divided by 2 is 7. Check, we are good to go. Okay, last but not least, all right, we have number 8, factor completely. This time, step 1, multiply the a and then the c value. So we've got 2 times 6 is 12, right? Now, remember, if they're 1 away from each other, 12 and 13, our factors are going to be use 1 as a factor. And since they're both positive, we've got 12 plus 1 is 13. And we know 12 times 1 is 12, okay? So our last and final step here, sorry about that, our last and final step here is, okay, write them in the binomial, x plus 12, x plus 1. Step 4, if our a value is 2, divide our a values into our factors. And the last and final step is simplify. So 12 divided by 2, that's going to simplify to x plus 6. And then 1/2 is not an integer. So I'm going to move this 2 value to the front and say 2x plus 1. Okay, and the last thing that I really wanted to show you, just because you can check all of these by using the area model. So if I wanted to check to make sure that everything was right, 2x plus 1 times x plus 6. So I want to check to make sure that I'm doing this correctly. And you can always check the area model. So 2x times 2 is 2x squared. All right, 1 times x is x. 2x times 6 is 12x, and then 6 times 1 is 6. You're going to see we combine the like terms, and this will simplify to 2x squared plus 13x plus 6, which is exactly what we had in our original expression. All right, hope this helps. Have a positive day.